Good morning, guys. So we're going to be doing some stoichiometry example problems. So we're going to find the chemical equation from the word equation, and we're going to determine the limiting reactant, the excess reactant, and how much of the product is formed. So for this first one, zinc and sulfur react to form zinc sulfide according to the equation. So to write the equation, we know zinc, which is Zn, react with sulfur, which is S, to form zinc sulfide, which is ZnS. So this equation is already balanced, so there's nothing we need to do. So, if 25 grams of zinc and 30 grams of sulfur are mixed, which element is a limiting reactant? So before we can determine which is a limiting reactant, we have to convert what they give us into grams, so we can compare it with the ratio. So looking at our equation, it's always written in grams. So here we see there's 1 mole of zinc, 1 mole of sulfur, and 1 mole of zinc sulfide. And so let's convert 25 grams of zinc and 30 grams of sulfur into moles so we can find our limiting reactant. So to do this, we have, 25 grams of zinc. To find how much it is in moles, we need to find how many grams is in 1 mole of zinc, which can be found on our periodic table, and the number written below the atomic symbol, the element symbol, the number under it is the molar mass, which is the mass in grams. So when we look at zinc on our periodic table, we see that it's 65.38 grams, and that is how much is 1 mole. So when we do this, we get 0.38. So we know 25 grams of zinc is equivalent to 0.38 moles of zinc. Same thing, you have to do the same thing to sulfur, so 30 grams of sulfur. Looking at our periodic table, it's 32.06 grams. So when you do this, grams cancels out and you get 0.93. So 30 grams of sulfur is 0.93 moles. Okay, and so now we need to find how much zinc is required to react with 1 mole of sulfur. So to do this, I'm going to put 0.38. Now technically you can guess which one you want to do first, but generally it's the one that will tell you which is less. So for this, in this case, this is moles of zinc and this is moles of sulfur. So here we know that 1 mole of sulfur requires 0.40 moles of zinc to react. Now looking at our equation, we know, see, this is, the ratio is 1 to 1. So when I compare it side to side, you see there is enough sulfur, but there isn't enough zinc, which means zinc is our limiting reactant. Because we see how this does not meet that. So zinc is our limiting reactant, and since there's only 2 reactants in this equation, the other one is the excess reactant. Okay, so zinc is our limiting reactant. How many moles of ZnS will be formed? So when we're trying to find how much product can be produced from our reactants, we have to use our limiting reactant. So our limiting reactant is zinc, which based on what we're given, we know that we have 0.38 moles of zinc. And we don't know how much zinc sulfide that produces, but looking at this equation, we see our ratio is 1 to 1 to 1, which means 1 mole of zinc will give us 1 mole of ZnS. So this is actually, X mole of ZnS. Okay, so when you do this, I'm going to cross multiply to get X equals 0.38 mole. And this question is asking for it in grams. Usually, if it's asking for limiting reactant or excess reactant, the amount, it's going to be in grams. Or if it says mass also means grams, unless it states that they want it in moles. But in this case, they want it in grams, so we're going to convert this into grams. So 0.38 moles of ZnS. Remember, this is moles of ZnS. So this is how much can be produced from this much. Now let's find that the molar mass of ZnS is 97.47. So when you do that, you're going to get 37.04. So that means 37.04 grams of ZnS will be formed. Okay, how many grams of the excess reactant will remain after the reaction is over? So our excess reactant is sulfur. So what they give us is they gave us this, and then we found this. So that's how much they give us. The limiting of the excess, to find the excess reactant, you take what they give you minus what the reaction actually uses. So there's going to be excess because our limiting reactant, there's no more limiting reactant to make more product. So we're going to take 0.93 and see how much 0.38 moles of zinc, how much of sulfur this much zinc needs to react. Now let's look at our ratio. Okay, so I got this from our reactant side. So you see 1 mole of sulfur and then 1 mole of zinc. So our ratio is just 1 to 1, which means 0.38 moles of sulfur is required to react with 0.38 moles of zinc. So that's how much the reaction uses. So this is in mole also. And when you do this, you're going to get 0.55 mole. Okay, but this is asking for grams, so we need to convert this into grams. So 0.55 moles of sulfur. How many grams is that? Okay, so that's your answer. So this is how much is left over. Okay, let's do another example. Example number 2. Silver nitrate, AgNO3, reacts with ferric chloride, FeCl3, to give silver chloride, Agcl, and ferric nitrate, FeNO3, 3. In a particular experiment, it was planned to mix a solution containing 25.0 grams of AgNO3 with another solution containing 45.0 grams of FeCl3. So the first thing we need to do is write the chemical equation because they don't give it to us. So looking at our word equation, we see that this reacts with this. So what I like to do is I just like to write it first and then balance it after. So we have AgNO3 plus FeCl3, and it produces, so to give, which means to produce, it produces this and this. So it produces AgCl and FeNO3, 3. Okay, so now we need to balance it because it's not balanced yet. So let's see, we have 9 NO, which means we're gonna need 3 of this, but now there's 3 Ag, so we need to make this 3. Yeah, now that's balanced. So you can check by seeing on this side, on the reactant product side, let's see, so 3 Ag, 3 Ag, 9 NO, 9 NO, 1 Fe, 1 Fe, 3 Cl, 3 Cl. Okay, so what's the limiting reactant? So just like before, we're going to convert what they give us, which is 25 grams of this and 45 grams of this, into moles first. So this is going to be, so I'm just taking 25 divided by the number of grams in 1 mole of NgNO3. And this is what you get. Same thing with this one. So you get 0.28 moles of FeCl3. Okay, so to find the limiting reactant, we need to compare with the ratio. So the ratio is 3 to 1. So I'm going to write 3 to 1. Now let's compare it. Let's see. So you have 0.15 moles of AgNO3 over, not over. This is just representing the ratio. And so you get 0.53 moles. So what this means is 0.53 moles of Ag, and it's going to be over 1. So 1 mole of FeCl3 requires 0.53 moles of AgNO3 to satisfy this reaction. So let's look at our ratio. I'm going to erase this and put this next to this. Oh. Okay. Well, you see 1, 1, and this is 3, but you don't have enough over here. You see it's only 0.53. It's less than what this reaction is showing us. So that means that the number on the top we had was AgNO3. So AgNO3 is our limiting reactant, which means this one would be our excess reactant. So AgNO3 is our limiting reactant. So next, what is the maximum number of moles of AgCl that could be obtained from this mixture? So we know that, so we have to use our limiting reactant to find how much is produced. So our limiting reactant is AgNO3. What they gave us is this much, which we found 0.15 moles from that. So 0.15 moles of our limiting reactant, NgO3, produces how many moles, X moles, of AgCl, because it's asking about that. So looking at our ratio, we see that 3 moles of AgNO3 produces 3 moles of this, which is a 1-to-1 ratio. But so just to keep it simple, I'm going to keep it as 3 so we can see how it connects to this. But usually you can just write 1. Right, so this is our product that we're trying to find how much it can make. So when you solve this, you get X equals 0.15, and this is the number of moles of AgCl that can be obtained. So from this mixture, you can produce 0.15 moles of AgCl. Okay, next, what is the maximum number of moles of AgCl that can be obtained? So these questions are basically the same, except this asked about moles and this asking about grams. So we just need to convert what we found here, right, into grams. So 0.15 moles of Agcl. What's the molar mass of Agcl? It is 143.32 grams, and that gives us, that cancels out. We get 21.50 grams, which is 21.50 grams of Agcl. So that is how much is obtained from the reaction using this and, this and this. Okay, E, how many grams of reactant in excess will remain after the reaction is over? So again, what did they give us? They gave us this, right? So the reason why we're looking at the number of moles for this one is because this is our excess reactant. Yeah. So 0.28 moles of that. Subtract how much the reaction used. So what I am doing here is looking at the ratio. We know 3 moles of this makes 1 mole, requires 1 mole of this to react. And so what they gave us is they gave us 0.15 moles of this, right? Moles of this. So how much of this do we need? So when you solve this, you get x equals 0.05 moles of FeCl. So what this means is 0.15 moles of AgNO3 requires 0.05 moles of that to satisfy the reaction. And to find how much is left over, you have to subtract it. Right? So how much they give us, how much we used, how much is left over. Now they're asking grams, so we just need to convert this into grams. This is mole of FeCl3. Hold on. Oh, I forgot a 3. Okay. What's the molar mass of this? 162 grams. Okay, so you get, cancels out, you get 37.31 grams. And this is the amount in excess in grams for FeCl3. And that's it.